So about 20 years ago, I was this nerdy guy hooking things to the internet, and I never really stopped. But how I do that now is quite a bit different. So pretty much everybody these days are familiar with things like smart plugs and smart bulbs and stuff like that. And if I asked you, what is this? Someone's going to say it's a light bulb, or, pick any one of these. You'd say that's a light bulb, but they're not. They're actually probably the cheapest computer you can buy these days. They have a chip inside that costs 25 cents, and that's how you can buy your bulbs at the big box store for 10 bucks a piece. But you look at that as still, it's just a bulb. We're going to cover today how to take these things, rip them apart, rebuild them, and write our own code and flash them. And also, we're going to hand out some flash devices. So we're going to turn some of these into good things, and we're going to turn some of them into bad things that will wreck your Wi-Fi with deauthentication attacks. So I think I have a good understanding of how a smart bulb works. Now, years ago, if you wanted to connect something to the internet, you would find people connecting a full server to a device. So it might be a printer. You wanted to have a printer on your network. You sometimes would share that printer over the network using various operating systems. Then I was in university, and one day I looked over at this table of printers, and there was a product called an Access print server. And I was like, well, this is neat. I don't know what this is. And I was learning about all things tech, started digging around on the internet, and I started learning about embedded devices. So at the time, embedded devices would usually mean you have something connected between a device like a printer and a network, and that allows that device to be shared. And if you start learning more about those things, most of them actually are running Linux for the most part. It's usually very poorly updated stuff that just works, and then it's out in someone's production environment for 20 years, never getting a software update. So that's the state of network appliances. And when I look around in a place like this, and I'm like, oh, hey, there's a Genie IP camera over there, and hey, there's another Lorex one. All I think of is the root password to that camera is probably 519070, because the code for some of these products is really neglected. And there's been a lot of interest in kind of coming up with a software practice and have like a certification for devices like that so that they're built with better standards. So let's go look at. I didn't do slides for this. I got all my code and everything tested, but I'm going to go through some of this stuff. And then the other thing I should make clear: feel free to raise your hand and just hit the pause button whenever you'd like if you want to talk about something. We don't need to wait to the end. So if you look at a device like this, we think of this today as a light bulb, and it comes in different forms. But these are the ones that I actually started learning on during the pandemic. We had a lot of free time. So I'm like, this is a perfect opportunity to learn how to write software for these things, and I hadn't done that yet. I like these ones when I found out about people online modding bulbs, because you can do this. You can pop the tops off, you can take them apart, you can look inside it. And if I turn the camera on the laptop, I'll show you what it looks like up close. But you can also take the bottom off of these. So we can take out the bottom part that screws into your plug socket. And that's because companies that build these products, they're shipping them out with a socket that'll fit North American, so it's the Edison E26 medium base. And in other parts of the world, they have a different push-in type lamp socket. But the guts that just fell out there, it's actually a little power supply, just like the charging bricks that power our cell phones up when you charge them at night. So they take these bulbs, they put a charging brick in there, hook it up to the high voltage power, the 120 volts or 240 or whatever you have. Then it goes down to low voltage, and it goes to a little computer inside this light bulb. So these really aren't light bulbs anymore. If you're buying smart bulbs, you have a computer with a peripheral, and the peripheral is, or peripherals, I guess. This one is a red, green, blue, white bulb. So what we actually have are power supply, a little computer, and this particular one is powered by an Expressive ESP8266, which is it might actually be the most popular computer ever produced, because when you think about how many people buy a MacBook, how many people buy an iPad, well, how many light bulbs do we sell per year, and how many smart bulbs? So the volume of this product and its 25-cent price tag, I bet you it overtook a lot of computing devices in just a short amount of time. So in this little bulb, we actually have a single chip computer, 1 megabyte of flash memory, and a voltage regulator. So for the non-electrical nerds here, the voltage regulator takes like the 3 volts or 5 volts or whatever, and it gets it to the right voltages to run the computer part of the bulb and the colorful lights. And once all that stuff comes together and the software loads up, it becomes the smart bulb, and you download the apps and you set it up to turn off and on at sunrise and sunset and so on. But you can do a whole lot more with these things. When you actually look at the circuit board, even on this device, it has TX, RX, and GND. And for the folks in here that are in that area right away, you're going, aha. because that means it has a serial console. Just like your router or other IT equipment has, you can plug this thing into your computer and you can watch it boot, just like any other device. And from that, people that were interested in home automation, they said, you know, I love home automation. I want all my stuff to be all automatic. When I walk in my driveway, it does things, but I hate the cloud and the internet's evil and I want to do it on my own. So they were modifying these devices with open source firmware projects. One of them is known as Esperna, which is Spark in the Catalan language, and another one is Tasmota. So these community projects spun up to take these bulbs from the cloud, free them, and then you can run them locally on your Wi-Fi network, and you can use Home Assistant to do home automation routines on them. And then people said, well, this is great, but can you imagine having to solder wires onto a whole pile of bulbs and start modifying them to do things? That's a lot of work. So later on, folks figured out the skills necessary to be able to do this. So these are these disposable bulbs that cost me a whopping $1.96 on clearance each. So you can take these things without touching them or opening them and erase the software inside and load your own code, whatever you like, and you have a computer. And for people who are hobbyists that have worked with Arduino or other devices, the Arduino is obviously a hugely popular hobbyist computer used to power all sorts of different ideas. Around 2014, people realized the same chip that's used to power these smart IoT devices was available for about $2 overseas. So that little thing shoved in here on the side, it's like a $2 board that gives this thing IoT. And it's kind of like a sidecar. So you have your Arduino, which is the device that can control things. Then you have your IoT device, which talks to the internet and can do things like go get the weather and turn on your cat feeder, you know, if it's sunny outside, whatever logic you want. You can write it into there and do it. And even the original, one of the co-founders of Arduino actually released a replacement CPU module that's plugged in here that has Wi-Fi. So you can actually take these old Arduino boards that have been around for a while and swap the CPU out and add Wi-Fi to them. But all this stuff costs money, I think. And this is the Winnipegger in me kicking in, but this $6 board is really expensive. And you know, it's amazing that you can do all this stuff, but we can do more with a lot less. So this was back around 2019 or so. A German cybersecurity firm named VTrust Security, they were interested in a product made by Tuya. So Tuya is this, what would we call them? They're an organization that's like a white label hardware service. So if you or I, if we have $10,000 in the bank, we can go to Tuya and start a smart IoT company. And for $5K, that gets us in the door, and for $5K per year, that gets us iOS and Android updates. So we can start shipping our product, and we just send them a bunch of money, and basically they brand this old package solution for us. We can sell cameras, bulbs, plugs, whatever we like, fish feeders, anything you want, you pick from the catalog, and they'll stick your name on the product and ship it out. And this German cybersecurity firm said, hey, it says military security. And that catches people's attention in cybersecurity, so they started paying attention to it, and they found it was not quite there yet. So a German maker magazine had actually published an article about how to convert devices from these sealed up bulbs. They found out that you could actually build a factory reflashing environment. And that's what we have running on this Raspberry Pi here. So that's why I asked, can make sure those light bulbs are turned off on the ceiling because I don't want to reflash this building. But
Speaking of that, I just heard from the venue that we should not actually do the reflashing because those are Wi-Fi bulbs.
Oh, okay.
I'm sorry to tell you that.
Are you serious?
Yeah.
That's less good, but that's okay. So I'll show you what it looks like, but we won't turn on the sending out packets because that would be less good. So the short story is these devices that are out there, there's some concerns with them that come out of the cybersecurity area. So the first is when they're mass produced, of course, they load a firmware that's loaded during the manufacturing time. And as we know, this VTrust security organization reverse engineered that firmware. They dumped the flash and had a look at it and found these critical vulnerabilities. The bad news is the default settings for millions of devices out there were to never receive a firmware update from the date they were manufactured. So they were activated, never receiving a factory firmware update, which means devices like those, if we turn on a device that produces the appropriate code, they'll start going, oh, I'm back at the factory, let me load the image. That's not something we want to do today. So there's a whole lot of security implications related to this. And out of the United States, they have their cybersecurity public information program. And one of the things they say to consumers who are not at all IT savvy if you have your guest Wi-Fi function on your cable modem or your fiber device, turn it on and put all your IoT devices on that. And like we all know as people with technical backgrounds, what that really means is segment your IoT stuff from the rest of your flat network. So if you're at home or a small business, you often don't have that level of support. If you use the guest network functionality, you'll segment it away. And by doing that, then these devices which don't receive firmware updates, at least then they're less impactful on your environment. So yeah, that sucks that we can't do any flashing, but I'm bummed on that a bit. But I've got enough here that I can show you. We can actually reflash these. What we will skip is the process of converting an unmodified device to a modified device, because that's the risky area that will convert any device within range. And on that topic, I actually, when I was learning this stuff, all of a sudden, John's plug connected to it. And I was like, what the hell is John's plug? And I'm like, oh, John's my neighbor. So then I turned my phone on and I went into pairing mode on one of these apps and I'm like, add plug. And it's like John's plug. And then I emailed John, who lives next door. He's a nice guy. And I'm like, hey, John, your smart plug's not working right, is it? He's like, no, my daughter came by and put it up with an Amazon device but hasn't configured it yet. And I'm like, okay, you might want to unplug it. But we'll go from there. So there's a process that you can use to convert these devices without opening them. So for the majority of these products, they're all running on one platform. As I said, it's like a white labeled solution by this company called Tuya, T-U-Y-A. We can go look at all this stuff in a few minutes. So Tuya sells an end-to-end solution, including the app, support, the whole works, and it's just a package deal. Inside of these products, I have one of them right here. If you crack the top off of these things, you can actually see it's just a bunch of LEDs and a Wi-Fi module in there. Now, when it comes to reverse engineering things, I've been doing this my whole life. One of the first places you can go look for to figure out how something works is the FCC ID. So everything that's an approved device in North America has to have a Communications Authority certification so you know that it's actually a good quality product. And if you look at these things, the FCC ID on them goes, you know, a bunch of characters, and that identifies the company that filed for the certification, but they actually have the letters TYWE3L or TYWE3S. And if you Google this stuff, it's actually the data sheet for that Wi-Fi module that we can see inside there. And we can sign up as a developer, we can get our SDK, we can build our own stuff. The whole works, everything is available to us. I'll plug in one of these here. Actually, I can start showing you the kinds of things we can do. And then we're going to go through how to build code, and we'll load it on here too. So this bulb, Halloween was last year around, you know, the time I started doing this. I called these spooky bulbs. A spooky bulb really just means we want to light up the pumpkin and look at scary or whatever. It actually just writes random brightness values out to the LED array. And this is about 3 lines of code. So this thing boots up, and you saw the boot time there. It's about 700 milliseconds, and it's just writing continual brightness values. So it has a random delay and a random brightness. That means that bulb is not a smart bulb anymore. It's actually an Arduino with Wi-Fi. And it's dirt cheap, so these are so an affordable product. We can afford to just give them away. And I actually gave away 2 bulbs here to someone that's here. I'm like, hey, if you think this is interesting, just take a couple, like, we'll be fine. Now, that bulb is online right now. And if I show you this in a second, we'll go, I have a router here on the table, and it's highly secure with the password admin because that's the default for this demo. We'll go in here and we'll look. And there is one of these actually I had 2 devices online. So one of these is going to get flashed. I'll have to ping it. Here, we'll go get some info 101. There it is. Okay, so there's that bulb that's pingable. And now, if I go over to Arduino, this is the code that's running on the bulb. So this is one that's been converted already. Actually, sorry, this one's just writing random garbage. I had, I think, a better random written to it before. But if we want to flash it now, wait till you see what we can do here. We go over this and we go to port, and it shows up on the network because it's actually running the Bonjour discovery protocol, just like an Apple device on the network. So there's my generic ESP module, and I can go compile it and upload. So if I just go upload, it's going to force the compile. I left everything all defaults for you. I built this last night, so password is just admin. And it'll compile away there, and eventually you'll see the code go spewing to the right, and then the bulb will stop flickering away. It'll talk to it, shut down the current process, and load the image over Wi-Fi, and now it's loading our code. So it'll finish in a few seconds there, and we just pushed an update out to it. So it rebooted, and it'll stop there. So this is another version of flickering away. So basically, you just saw an over-the-air firmware update to a bulb that's never opened. But let's go backtrack this, and we'll cover a whole lot more information here. So let's see. I'm looking at time. We're 15 minutes in. We've got about, what, half an hour still left, right? 25 minutes. We're good for time. Let's go stop and backtrack where we are to get to this point. Let's see what we can find here. VTrust. I'll see if I can find the actual paper they published. But there's some really good YouTube videos for this too. Let's see what we got for this one here. So you can see that we have a whole pile of these TY modules. So what we actually have are inside these products. There's an FCC certified device that's sold as a whole computer in a module. And that allows companies that use this to avoid the certification process. So every time you're producing a product that has a radio transceiver in it, you have to go through an engineering test and get it certified. So companies have gone through the trouble to make a pre-certified module. It's like getting fast food. You plug in your module and you're ready to go. I want to find the technical details for the VTrust stuff here too. But here we'll also show you Tuya, so you actually have an idea of what this company is. So look at this, smart devices IoT platform. So this is back to what I was saying. It's like a white label IoT provider, and they have, this is, if you're going to the big box store, whether it's like a Walmart, a Home Depot, London Drugs, Canadian Tire, any of these places, and you're finding products on the shelves that are saying smart bulb, I can tell you that is a very high chance that it's actually just another label of one of these devices. So pretty much every category of device you can find, including those, oh, sorry? Oh, yeah. Yeah, like basically every category of IoT product is already available for you here, right down to a smart scooter, which honestly I didn't even know that exists yet, but sure. And you can go here, you're thinking of us as a technical person, you have to think of it more as a business and an investor person. So what's your goal in these companies? Do you care about smart bulbs, or do you want to make some money? And what the companies are doing is they're coming to an everything provider like this, and they're saying, you know what? We have a market for smart bulbs. We have a market for smart scales and these kind of products that you find in stores. And all it is a business venture. So they're going there, they're providing their graphic designer, here's my brand, here's my logo, give me an app, provide the updates. And really for an affordable price, you end up launching your entire product. Like, look at this, your logo. Like, there's no secrets here. Like, this is literally, this is your IoT shopping mall. And out of all of the products that are out there, I don't know if they actually have the story about their brands here. This is the majority. There's probably 90% of the stuff that you're going to find in big box retail, even on Amazon, all of these products with different names. This is the back end for it. And we talked about, an aspect of this too. When it comes to these apps, the companies that are subscribers of this whole IoT end-to-end solution, they often don't publish app updates. So you can actually have these types of products can be in your home and never have received a firmware update since the day they were manufactured. And as a result, when you have a tool like that flashing tool that we have here, even if the devices in this room are already installed for like say 3 to 5 years, it's quite possible you could turn them on and we could actually like all of a sudden it'll say four MAC addresses have registered, and you're like, that's not good, because they have never received a firmware update. And if you do have these kind of products in use in your home, certainly take the extra 5 minutes to go look in the app. And unfortunately, there is no global firmware update command. You literally have to look at every single device that you've set up and go in the settings and turn on update, then try to update it again before you finally get it to do that. So certainly an area that needs more attention. Now, to Tuya's credit, after they learned about this conversion process, I think they did see it as a security issue, and I think any of us here would too. Like if I told you I can go up to your house, take your bulb, dump the firmware, and get your Wi-Fi password out of it, you'd be like, I don't really like that. And that's the truth. Like I'll show you some of the things that are problematic there. So they have corrected the vulnerability that allows you to reflash them was corrected fairly quickly. And that's why I went looking for older inventory like this produced in 2019. So I know that that hasn't received any firmware updates. But for the vast number of units that are already deployed, there's a real potential for misuse. knowing that these devices have 1 or 2 megabytes of flash memory, generally one you can 100% assume there's nothing less than that. Your code's only about 300 or 400 KB. You actually have 2x the amount of space you need to make these products functional. So there's one day, I'm going to throw this out here because it will take place. Someone is going to do something stupid with IoT that results in something that goes from like bulb to bulb to bulb to bulb or plug to plug until it can't reach any more radio range. And just like that, that takes me back to old times with like Windows XP and those Sasser worms and stuff. It was like 2003 and you're like, another one's infected? But it's, like that's kind of, that incident, I don't think, to my knowledge, hasn't occurred in IoT yet. I mean, someone else can correct me, but I don't think we've seen those kind of problems take place where you have worm-type malware on it. And it's entirely technically feasible that could happen. Let's jump back to do a little bit of stuff with the vTrust part of this. So here's how this works. The team that created this, they had no malicious intent. The goal is actually, if you're a maker, you're building projects with things like Arduinos, and you can look at these devices, whether it's in a light bulb or if it's just a bare circuit board, you can buy them in different forms, and you can say, you know what, I want to build this new idea, I want to convert it. And the files that would actually come with these tools, they actually were intent on converting them into just cloud disconnected bulbs. So those Asperna and Tasmota files actually come with these conversion tools. So they'll reprovision the bulb and flash it. But we can actually create our own bin, and as you saw, we created that Arduino update and then we loaded it into the bulb and the bulb rebooted and took our code. So the missing part here is actually that conversion piece, and that's what's accomplished by starting up this firmware flasher routine. So the conversion process kind of follows something that's interesting related to how these devices work. So when you first buy these smart IoT devices, everything made by that one brand that powers the majority of them, they have a feature called Smart Config. So if I go open up a new bulb here, I'll show you what this looks like. So I can do that without dropping it. So when these products are initialized right out of the box, they're designed to be easy for customers to activate. And to do that, they came up with an interesting protocol that I'm sure some of us here would be like, really? So when the bulb powers up, it's actually listening for a broadcast packet in plain text with your SSID and your password. So the app is coming up with a broadcast that says, here's my network name and my password. It actually reminds me of WPS and all those problem solutions that people came up with for extracting WPS passwords out of routers and things like that. So these devices, when they're purchased brand new out of the box, they'll boot up and they start flashing fast if they're in easy setup mode or slow if they're in AP mode. So this one's actually interesting. This one's on. That tells me it's actually not a new bulb. A new bulb would not do that. So that's interesting. Let's try number 2 and see if we have better luck. Yeah, that's interesting. Those devices may have actually been returns. So when these products are purchased brand new, they have an easy setup mode. I think, actually, you know what? I don't know what I'm thinking. I've got 100 in here. So there's, you know what? When you find stuff, I'm like, you know what? I got to stock up on these. So there's 100 of one model that will be ready to go. I mean, they're $2. Like that, seriously. How much computers can you buy for $200 these days? And no, I don't have a problem. Even my kids ask. So that should be a brand new unit. And this is interesting. That's more like it. So those other ones are actually returns. So that's a giveaway because if they're new bulbs, they go into this setup state. If they're used bulbs, they stay in the previous power state that they were on before they were returned. So they were on and then returned. The easy setup mode is terribly insecure, and this thing is horribly vulnerable right now. It's waiting for someone to just tell it what to do. It'll receive a packet, and it'll join that network, whether it's a server that impersonates the factory or whether it's an app on a phone that's broadcasting it. There's another mode that these devices go into, and it's called access point mode. So if you power cycle these types of products 3 or 4 times, it'll put it into an AP mode where it generates a soft access point, and you can connect to them. Now, the easy setup mode, it works by the app on the phone. You enter your credentials, and it starts a timer on there for about 2 minutes, and it keeps just blasting out your wireless network name and the password in plain text. So during that setup process, if you're working in the, I don't know, security industry, I don't know what you'd be doing with a residential user, but I can tell you that if you just listen for these broadcast packets, you're going to have people broadcasting their correct network credentials during their setup process. And that's an area, that was the first thing that came out of all these revelations about how IoT devices operate. And you would say, well, like, that's terrible. Like, we should have a different process. It should be encrypted at least, or something could be done differently. And when you actually think about the fact that that's all is plain text, so here's something we can't do the full end-to-end test. If I go to some archives out of this, let's see, this is from last night. I'm typing left-handed too, so it's not so easy, but here. Where is it here? There we go, and in here, these are all the logs from, I think the one that's flashing like crazy that's around here. This was the actual conversion log from it last night. So this file that you probably, I'll see if I can zoom in on here a little bit better. This firmware file that we have here, that was actually the factory stock firmware that we extracted off the bulb during this conversion process. So not only do you actually wipe it, you actually dump the entire flash. So if we run the strings command, if I could tab properly, strings, let's try this here. Actually, I got to do strings, where is it here? There we go. So one of the things that we see at the end in plain text is just the password, and it's dumped right in the firmware that we extracted out of that bulb. So we can actually see some other stuff there that let's not leave in the video, because that's like the full signing key for the back end and all that stuff, because they actually have the whole configuration for these devices, including the keys that it talks to the cloud infrastructure. It's just sitting there in plain text. And yeah, no kidding. That's you. Now you're starting to see how this security firm is like military security. Are you sure? Let me check that. So the flash chip obviously is really easy to extract. So for people that are doing reverse engineering, you don't have to get fancy here. You can just desolder this with a soldering iron and go drop it on a USB programmer. It's not like super high tech. And I'm sure that's probably how the folks started on that whole area. Let's see, where should we go from here? So this bugged me that we can't do conversion, but I do have some devices that we can flash. So in addition to flashing Arduino conversions, obviously you can, I think you guys get where my intentions are. Getting into this space, have time during the pandemic, I'm really interested in converting low-cost computing devices into things that I can build projects with. So what would you do that's legitimate with a little computer like this? Well, you can take things like these plugs, which again have the same chipset as a bulb or a fish tank feeder or whatever you have. They all have the same guts inside. And I had a friend that has a manufacturing business, and he says, William, I got a water solenoid that I turn on one of my pieces of equipment. I need an interval timer that can just pulse this solenoid to wash my parts as they're going through a metal tumbler. And I said, you know what, we should totally take a smart plug and just do that and load a piece of code in there that can turn off and on a relay. So it turns on for 15 seconds, it does its cycle, it pauses for 5 minutes, it's just a repeating thing. These are interval timers, stuff like that. So those are the kind of things that I was interested in, not doing less good things. But I'm gonna show you some of the less good things that you can take these hardware for. And I don't think I can flash anything here, but I probably have some stuff I can still give away. So here's an example of, this is a smart plug and it's a relay, but now it plays music through the plug instead and goes ha 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 with the devices plugged in. So if we plug it in. So that is, that's not as, yeah, you guys like that, huh? So I really wanted to get the notes for Rick Astley's song, but at the same time, I'm like, you should probably just let that go. You can also take these devices, and they're actually fast enough that you can write software to bit bang out the GPIO, an analog television or radio signal. So there are some examples you can find online that'll modulate a channel 3 analog television signal complete with color with games running on it. And that's because the processor is so fast it can modulate 59.75 megahertz, and that's the channel 3 television frequency. So you can create it, yeah, no joke. So what we're looking at here is like, honestly, this has got to be the cheapest computer money can buy these days. So that's one chip. It's also important to, I haven't even got to the other parts of the things to discuss yet, but there are competing products to this. So I've talked here, for like half an hour now about one particular vendor and their products, which are highly flexible. Everyone knows about Realtek in here. Realtek's been making network cards and sound cards forever. They saw this and said, hey, we got to get in on the IoT business. This is a Realtek-powered plug. So this one, again, has a little module here that we can see, just a little wafer of a circuit board. Unfortunately, there's not really the same development tools that are available for this stuff. So this is just junk in my bin for now. It's a very valid plug that works fine, but it's not developer friendly for community projects. It's basically closed source. Where in this case with the expressive products, if you're into IoT as a hobbyist these days, the ESP8266, the 8285, and the ESP32 are very friendly to developers. You can go and download all their tools, complete with virtual machine images for their SDK, and if you want, you can find companies like these large organizations that will help you develop your IoT idea into an end-to-end business complete with app support. So very different. However, now you want some bad stuff because I know we're getting near the end of our time today. There's a de-authentication attack image that was compiled for the ESP8266. It's commonly available as a watch you can buy on Amazon. So if you go on Amazon, you look for a de-auth watch, it's like $60 online. However, you can take the same code and you can load it into a device such as a plug or a bulb. So for the folks in here that are into like the red team of security, here's a smart plug that'll perform Wi-Fi de-authentication attacks until it fails. Here's a bulb that does the same thing. So this bulb looks like it's dead, but actually it'll ruin your Wi-Fi or whatever Wi-Fi you choose to tell it in its configuration until someone finds it and removes it. And when we turn it on, it'll create an SSID that we can connect to, and I can't remember if I left this default or not. But let's see here. Oh, I like your SSID. It looks like a little tower, very creative. Let's see what we got here yet. I don't know if that one's online yet. The lamp actually, if I turn it on, it does nothing because that's part of the code. So it's a dead light bulb that's a de-auth Wi-Fi device. Remember I gave a couple of these out in the talk at Skullspace earlier. See if these are configured. And again, I didn't actually test these particular ones out. I was going to flash some new ones, but we'll see if these things come back online.
So, question.
Yeah, of course. Absolutely. I can actually, so it's not my stuff, right? Let's be good. Let's not touch something that's not ours. But the reality is when you're doing that conversion process, it loads effectively like a new bootloader on the device. It dumps everything from it, and it leaves all that stuff behind. So if I go look at this directory here, let's see. So it writes out all these files, including the original firmware and everything that was on that device. So right down to the device's unique ID so that you could tell that this is like plug A or B. You could actually mod something, save these files, play with it, and then return it, reflash it back when you're done. So yes, you can. You can unbrick not unbrick, but you can undo your changes if you're careful. And that's another space too, Robert. Like these bulbs, you can take them apart, right? This is not a common device. These things are glued together. There's zero room for error. If you make any mistakes, you've created e-waste. So that's the unfortunate part of those devices. So I don't know if I actually saw an SSID show up. I think, if I remember correctly, I was actually de-authing myself at home with this one. Oh no, there it is, Pond. That's the one. Let's connect. Not automatically, I don't want to join that for a regular basis, but here. So here we go. And let's go de-author. No, I just don't want to connect. So if this is correct, no, hold on. I wonder if I changed the password on this. Let's take a guess. That's not the one here. Yeah, let's try this again. No, okay. Sadly, I don't know what the password is for that one at the moment. But when you flash the ESP deauthor, basically it gives you a web interface and then allows you to select the target network by SSID or MAC address. And once you've saved that into these devices, it's committed to flash. And as long as power is applied, it'll continually perform deauth attacks against it. So there's not really any good purpose for doing that other than the fact that it's a good demonstration of what's capable for that hardware platform. There's also a number of really interesting projects. So obviously, for the folks here, out of this crowd, how many people are familiar with Arduinos here? Is it? Oh wow, It's like every second person, so or maybe even 2/3. So for folks familiar with Arduino, here's the Arduino IDE. These devices, you can just reflash them into Arduinos, and you can load your own code on there. You can come up with whatever ideas you want. You've got $1.96 gets you this device. That's amazing. And if you want to control AC powered loads, these things, they're CSA approved, and they're good for about 10 or 15 amps of current. So you can really, if you want to control something, it's probably the cheapest way you could build a project. Now, there's obviously different firmware builds that are out there in the community. So I talked about the Tasmota and Asperno ones, and since I can't show you the D-Author, let's see if I can show you one of those. So I should have a good collection here. There's alternate solutions that you can build too. This one actually has, there's an OTA image loader that you can flash onto these too. So if you wanted to sell these products as a maker-friendly or hobbyist-friendly device, you can actually put a web page loader on it that'll just say select the bin file and go ahead and load it up. Let's see here, what do we got here? So here's Tasmota. So Tasmota is one of the popular Home Assistant cloud disconnected environments. So that one's booting up, and this is like the default for Tasmota. It's blinking slowly, very similar to the factory firmware when it's in its configuration mode. So we should see an SSID appear because the bulb's going to run a soft access point. We'll see if we get something coming out of it here. Maybe not. If you guys Google Tasmota, and you can play capture the flag with this bulb if you like. There's no way for me to ever reset it. You can claim this as yours if you're fast. Where is it? There we go. I saw Tasmota. There we go. So, and there's no password on this one. And it's going to, oh yeah, so Windows is trying to see if I've got internet. Look at that. So it's running a web server, and it'll connect to whatever network we like. So from that, we can save our configuration. I'm going to power it off because honestly, someone will play capture the flag here. If you do, I'd be like, you might as well just have it. There's really no way for me to reset this thing. There's no way out. But you can see how this type of firmware works. So if you're a hobbyist and you want to build a cloud-free home automation system, you can take these devices, which are modifiable, and you can load these alternative firmwares in there. This really takes me back to the days of things like DDWRT and Tomato on the old Linksys routers. Same idea here, only now we're into a new world where we're playing with $2 computers that wow, if you think of it, they're not that far off from what those routers were back then. So that's one of the different firmware builds that we can load. The other one here I should have is Asperna. Actually, if this one is legit, I don't know what's on that for sure, but we'll try it. Yeah, so it's like, what do you got in your bin? I've got my dev test prod of light bulbs, but here, that was a TV transmitter. And there's Tasmota again. We'll see what we got here. Yeah, it's not a good quality. Some of these are actually stock. I think I should have, I might be all out here. But yeah, I don't think I have any other firmware builds flashed there ready to go. So that's probably as much as I can cover with what I've got here for equipment. Certainly, I've rambled here enough. Did you have any questions you'd like to ask regarding this stuff? And hey, go ahead. Someone, whoever, take your... Yeah, absolutely. I mean, think of where you'd put a light bulb as... Oh, absolutely. So the question was, what do you think the temperature range of these products will operate in? And of course, I mean, when you're buying a product like a light bulb, you can expect that some of your customers are going to place that device outside in an outdoor light. You actually, if anything, you might be facing an over temperature problem more likely, because some of the outdoor lights and indoor fixtures, these are often rated as not for a sealed enclosure, because the heat that's generated by the power supply actually will overheat the product more than anything. So outdoor, I would suspect you never have an issue in an enclosed area in the winter, and in summer, if anything, over temp. But there's no temperature sensor in here. So unfortunately, I don't have anything like that. However, if you want to be crafty, you can do other things that I've messed around with. Like you can look for, if somebody walks too close to this device with their phone and it's beaconing in 2.4 gigahertz looking for networks, send me a silent alarm that I've got someone lurking by my car. So you can use it as a Wi-Fi sniffer that sits there in passive sniffing mode collecting data, and once you trip it with a signal level over a certain threshold, turn on the AP or the client mode, connect to the network, send a push notification through pushover, and then go back to sleep. So you can do some fun stuff, and literally, it's Arduino, right? Like that's super cool for a $2 device. Sure. Oh, there.
You mentioned that the ODM released a patch for the original exploit kits.
Yeah.
Is there a good way to get new stock of this sort of thing, or if you bought up the entire market?
No, I think you can actually go online and find it. And one of the home assistant crowd has been buying these products because of home automation was a key driver. They were struggling with the same thing. They would say, I want to do this, but I don't want to have to buy and return 10 bulbs to get one that I can flash. There are manufacturers out there that are just selling pre-flashed devices. So if you had an actual idea here, you can go to the OEM manufacturers and say, I want my firmware, here's my bin file, I want that loaded on the products. It would take more coordination. And I didn't try and buy out the whole market. Like folks like because I know through the University of Manitoba, I said to the engineering students, look at this cool stuff and look what's on sale. And I think some people actually did go out there and buy some of the inventory. But in the end, I bought about 120 units. And they're sold in packs of like 2 and a plug was like $6.96. So yeah, I spent a little bit of money on it, but I'm happy to actually give some out here. That was part of the fun. So certainly we should throw out some random unflashed bulbs today. And if you want to play with them, go nuts, have fun. I've got plugs and bulbs. I'll give out a bunch here for the folks that are interested. Go ahead.
So there's no real way to flash any of the newer 2 bulbs?
Actually, this is where it's maybe. So remember that the firmware updates were not something that was a default setting. So you entirely could have a device sitting in your home that's your smart bulb in your living room today. And if you choose, you could try running that against it and say, oh wow, I just reflashed my living room bulb I've had for 3 years in there or 5 years. And it could be in exactly that situation. But in terms of new stock, you're probably not going to find in the retail stores at this point. However, there's a nice feature of these products, whether it's sold at the Source, Canadian Tire, or wherever you go, there's a date code on this product. So it says 09A19, September 2019. I know that's going to have old firmware. So if you're actually out there and you want to do this, you can go shopping and just go look for the dates on the product packaging. Try and find something before 2020 and your success rate should be 100%. If it's around 2021, somewhere, I don't know the exact date. The folks online that are obsessed with home automation probably have calculated the precise build number by now. I don't know that. Go ahead.
It's been pretty interesting, especially regarding to provisioning. How does it compare to provisioning for other products that kind of do the same thing, like for example, Roomba?
Yeah, that's a very good question. So products like Roombas, Dysons, and other devices, they're all like, IoT is a big thing. Like everything's got a system in it. You'd have to look at it on a per device basis. So if you want to go look at what's inside your Roomba, first thing is go take a picture of the label on the bottom. You're looking for the FCC ID of it. Go to FCCD or FCC ID search in Google, type it in, go look at internal photos. So if we go to do that on we probably could figure this out right now. We need to find a picture online with Roomba's FCC, go look it up, have a look inside, and we're going to find what embedded system they're using. So once you know a little bit about it, you're going to know what kind of platform it is. Like a device like that's a more expensive product. It's not going to be probably not running off a microcontroller. It's probably a little embedded Linux system or VxWorks or something like that. But certainly start with FCC ID and go from there. And if you really want to mod it, you're going to probably have to open it up and then start playing. You're going to find a serial console. Next, go on Amazon, buy a little USB serial adapter, and go watch it boot and sit there on your desk. And maybe just drill a hole in the top, put like a headphone jack on it, hook up a serial console, and then you can really have fun with your hacked Roomba. Anyone else, or are you all out? Sure.
So with the security implications for the open provisioning of just this incident of a smart device,
Yeah.
the best defense is still home network segmentation? Is it still having your separate IoT network so that if we do have a vulnerable device, the attack surface is limited?
I can tell you that I never used to pay attention to segmenting IoT until I did this stuff, and I was like, holy, that's not good. So I was before in the mindset of, it's just my house, I'll put this stuff on it. But the easiest thing you can do if you're using a service provider or router is they all have this guest function on there now where you can enable an additional wireless SSID. It's segmented from the rest of the home, and then just come up with an interesting SSID and password. Put all the IoT devices on that, because by default you're sharing you're still natting the traffic, and you've got the same public IP, but now your interesting, poorly maintained IoT stuff is not going to potentially be prodding at your Windows machine or other devices on the network. But I mean, how about just the security hygiene practice of never doing a firmware update on something? If we said that, and if I said I never am going to update Windows on this, it's built for life, you guys would be like, you're nuts. But that's really what's going on in here. Like, there's a manufacturing software build is loaded on the device. The defaults are no firmware updates. How many consumers do you think are going to do firmware updates? It's like, like the 1 in a million. And even that, when it comes to doing the updates, you actually have to go device by device through these apps, and you have to turn it on for each one. Then you have to force it manually. Like, you'd have to be obsessed with this stuff to go to that level of detail. So that's why I'm glad they turned these lights off. And I can tell you, as soon as I saw the lights in the room and someone said they were purple, I'm like, uh-oh. And, the likelihood is you could probably pull one of those as an example, and we could probably fire up our process and repurpose it. And I mean, that's a real not good state of consumer tech there. So is it giveaway time? Oh, one last question.
Yeah, you said that the device or your phone, whatever, broadcasts plain text.
Correct.
How does it broadcast that? Like over Wi-Fi?
Correct. Yeah, it's just blasting out like, hey, here's my home password, super skier 1234. Yeah, it's just broadcast traffic. It's just trying to the bulb's just listening for, and you're trying to throw it at it, and somehow it gets there. So, if you think about that, if you wanted to make this provisioning process better, if we're a tech savvy person, we understand what wireless APs are. We can connect to an AP even if it's got no security on it. Probably that's a less dangerous provisioning method for this particular type of product, because at least then I'm not blasting it 18 times out. I'm just connecting and sending it once, which is not awesome, but it's fewer. But then this gets back, like, you can extract the key out of the firmware for the product. It's stored in plain text in the device. Do you really want that type of a device on your network next to your work laptop and everything else? Probably not. It's an opportunity for someone to go get your credentials easily. Yeah, I mean, like, if you throw out a device now, it's like throwing away a computer with your key in it. You're right. So we can look that up. Check this out. There's a nice data sheet for it we didn't get to. So TYWE3L. And if I could type, hold on here. 3L data. Yeah. Oh, well, hold on here. I got to fix this quick. Let's go back on the Wi-Fi. Yeah, that'll work. Oh, that's better. Okay, let's try reloading that. I was worried. I'm like, is someone going to be packet capturing and DDoSing people here or what? You never know. So here's the data sheet. So like the TUI organization is actually really amazing. They have all the developer stuff here. Check this out. So that not only are they ready to say, hey, we'll make products for you, like here's the data sheet. Here's the specs for it, 32-bit CPU, 2 meg flash. And here we go, 9 GPIOs, serial port, analog to digital converter, and it runs at 160 megahertz in turbo. That's crazy. This is a light bulb or a plug. So when you see these things, you're going to be like, the thing is, you know what? If someone was up to malicious activity, and hey, here's your temperature specs you asked for, so they officially spec it as minus 20 to 105 C. But I can tell you with the light bulb, it generates so much heat that in the winter here, you're not going to have a problem. It's hot, if anything, but a plug might freeze. Like the plug could fall below temperature. It doesn't have anything on board that generates enough. So here's all the potential places: baby monitors, webcam, intelligent bus. Now that scares the crap out of me. I do not want to get on that bus. But there's what the module looks like inside. And you can absolutely extract these out of here, and you could actually take a cloud authorized module and go build your own hobbyist project with it. So you could take a plug without modifying it, crack it open, desolder that module, and you could put it to control something on solar power in your backyard if you want. Yeah, it's super cool. And you can buy all these things, of course, online now through all these marketplaces. Yes?
Who do you think is in the best position to solve
Well, this is one area which I'm definitely not a person that says regulation is a good thing. But you have to look at this and say, what if we had standards like there's been talks in the past about having software security standards, and that topic has come up a number of times in the last 5 years with things like home surveillance systems that have hard-coded passwords and things like that. I think it's almost at the point of some of the stuff that's out there, you need to have standards and have like a green check mark on it that says it meets Canadian standards or American basic standards, and you can say that's what the product is. We know it's got secure coding practices. We know there's no hard-coded backdoors, stuff like that. Excuse me.
So would you put that into like FCC now has to contact like NIST and understand how to apply those standards to get some third party to sign off on change?
I think it's probably, if you look at a device like these already, there's multiple standards and organizations that are responsible for it. So there's a certification from a communications authority in whatever country the device is used that says the radio is okay. So the radio part of it is a pass for Canada, for United States, wherever country. Then you have a CSA or UL certification that says this thing is going to be plugged in and it's electrically safe. So if anything, it's probably another type of organization would say this device meets modern secure programming standards, it follows best practices and so on. And by doing so, you'd probably eliminate things like plain text SSIDs, you'd have some encryption there in places. Like those are some standards that any one of us who've worked in the IT industry would say, like, I think I see a few gaps in that we probably would fix, but we can't. So I think that it's going to come, because you're seeing just the volume of this stuff out there is insane. Like you're shipping millions of units out there, and consumers that have, they don't have those IT skills, they're going ahead and plugging it in and deploying it. Okay, should I start throwing some bulbs out to people that want to mess around with this stuff?
Please don't throw bulbs.
Okay, how about, can you help me deliver some nicely to people who are interested? Hey, who wants a bulb? I'm just curious oh wow, okay. How about we'll cap it at like 5? And is that fair? I don't know how many people put their hand up, but here's a bag. This is all ones that are good to go. I'm just going to grab 5 out of there. These are unmodified. You're going to have to learn about all this stuff yourself. Can I give you these to distribute?
Sure.
They're fine. There's 4 of them. I'll give you like 2 more. That's 6. Then I think we're good there. I think I'll be okay too. My kids would be like, Dad, you don't have as much of a problem as we thought. You gave away some.
You get a bulb.
Yeah. All right. So those devices, if you want to learn about it, you're going to need to look up Tuya Convert, and you can, you'll need a Raspberry Pi in probably about 2 to 3 hours to get the crash course down. When you understand enough of it, you'll end up with a Raspberry Pi and your lamp will connect. And I also give you the fair warning of be careful with your neighbors depending on where you live, because if you have a good relationship, you should keep it by not reprovisioning their smart home. Yes?
Do you recommend any specific version of the Pi, like Pi Wireless, Pico?
This is actually, so I'm using a Pi 3 just because I happen to have a couple of these kicking around right now, but it's any version of it that has anyone that has a wireless radio, because we're running this as an access point. And then to connect to it, I'm using wired Ethernet. So you probably want a regular Pi. So I have a SSH terminal session and I have an SCP session. And what I'm doing there is I'm building the Arduino on the PC, exporting the bin, SCPing it over, and then flashing it. So there's a few steps involved, but it works well and it's not horribly expensive.
So rather than just putting the bulbs on like your own network, you're using the Pi as a gateway for it, almost like say a full system having a way?
Not quite. So this Retro Linksys router here is actually your SSID. So if you've been watching your SSID appear, this is the mystery device. And it's that's the programming examples that Arduino provides. So this is all default. Like all I've done here is basically I've replicated like a default setup for doing Arduino IoT. And the other thing that, I know we're out of time, right? Yeah, the Arduino IoT, go Google it because there's a cloud version of it. You can actually do your own cloud-based Arduino if you spend the time to learn it. Thanks very much.